When people talk about matter, they usually mention three states: solid, liquid, and gas. But did you know there's a fourth state? It's called plasma, and it's everywhere in the universe. In fact, 99% of all matter exists in this plasma state. You might not see plasma every day, but it's closer than you think. From lightning in the sky to neon signs and even some light bulbs, plasma is all around us. In this video, we're diving into what plasma is, how it's created, its properties, and some cool ways it's used. Plasma is basically ionized gas. Gas whose atoms have lost or gained electrons, turning them into ions. It's not a special type of material, just another state of matter like solid, liquid, or gas. The story of plasma begins in 1879 with British scientist William Crookes. Using a special tube called the Crookes tube, he noticed a strange glow. Back then, the structure of atoms wasn't fully understood, so Crookes called this glowing matter radiant matter, but it was actually plasma. Later, in 1928, American physicist Irving Langmuir confirmed this and named it plasma. Plasma is created when a gas is given so much energy that its atoms break apart, losing or gaining electrons. This process turns the gas into a soup of charged particles, ions, and free electrons. Here's a breakdown of the three main ways plasma can be formed. The first is heat. Every solid object can be heated enough to change its state. For example, if you heat a solid, it melts into a liquid, and with more heat, it becomes a gas. But what happens if you keep heating a gas? Eventually, the atoms inside the gas get so much energy that their electrons are knocked free. This turns the gas into a plasma. Stars, like our sun, are made this way. Their incredibly high temperatures, millions of degrees, strip electrons from atoms, creating a massive ball of plasma. On the sun's surface, temperatures reach 5,500 degrees Celsius or 9,932 degrees Fahrenheit, and at its core, it's even hotter, about 15 million degrees Celsius. All that heat keeps the sun's plasma state stable. The next is electricity. Another way to create plasma is by using electricity. When a high voltage is applied across a gas, it can knock electrons out of the atoms, creating plasma. This is how neon signs and fluorescent lights work. Inside these tubes is a low-pressure gas, and when electricity flows through, it ionizes the gas and turns it into plasma, which emits a bright light. The same process happens in lightning. As clouds build up static electricity, the air between the clouds and the ground becomes ionized, creating a path for a massive electrical discharge, lightning, which is a form of plasma. Plasma can also be created by bombarding a gas with high-energy electromagnetic radiation, like ultraviolet, X-rays, or gamma rays. These rays are so powerful that they knock electrons off atoms, ionizing the gas and forming plasma. This is what happens in the upper layers of Earth's atmosphere. When ultraviolet radiation from the sun hits the atmosphere, it ionizes the gases, creating a layer called the ionosphere. This plasma layer plays a crucial role in reflecting radio waves and allowing long-distance communication on Earth. Each of these methods gives enough energy to gas atoms that they break apart into ions and free electrons, transforming the gas into plasma. However, for plasma to stay stable, energy must keep flowing into the system. If energy is cut off, like when you turn off a neon light, the plasma reverts back to a neutral gas state and the glow disappears. Plasma may seem exotic, but it's actually the most common state of matter in the universe. While we're more familiar with solids, liquids, and gases here on Earth, plasma makes up 99% of all visible matter beyond our planet. Let's dive into where plasma can be found, both in space and on Earth. The vast majority of plasma exists in outer space. Every star, including our Sun, is essentially a giant ball of plasma. The high temperatures in stars strip electrons from atoms, creating a sea of ions and electrons that form plasma. Not only stars, but the space between them, what we call interstellar space, is filled with plasma too. This plasma consists of ionized gas clouds and dust particles that drift between stars and galaxies. In space, plasma is incredibly energetic and it's constantly moving. For instance, our Sun generates solar winds, streams of charged particles that travel throughout the solar system. These solar winds are made of plasma and can even interact with Earth's magnetic field, creating phenomena like the auroras, the northern and southern lights. While plasma is everywhere in space, it's much less common on Earth, where most matter exists in solid, liquid, or gaseous forms. However, we still encounter plasma in several natural and man-made ways. For example, plasma TVs and plasma balls are used in many modern technologies that harness plasma. Plasma TVs use tiny cells filled with ionized gas to produce high-quality images. Similarly, plasma balls, those entertaining globes that create colorful electric arcs, use plasma to create a visual effect by ionizing the gas inside the glass sphere. Plasma welding is also a powerful and precise welding technique that utilizes plasma to join metal components. It's an advanced process that builds on traditional arc welding, but uses plasma as the medium to conduct the electrical current and generate the heat needed for welding. Plasma welding is often used in applications requiring high precision, such as aerospace engineering, electronics, and manufacturing. The plasma welding process works by forcing an electric arc through a small nozzle to constrict the gas, creating a high-velocity stream of plasma. This plasma stream is extremely hot, reaching temperatures of up to 25,000 degrees Celsius, and can easily melt through metal, making it perfect for welding. Scientists continue to study plasma because it behaves so differently from gas. In fact, they've discovered other strange states of matter, like the Bose-Einstein condensate, which occurs at super low temperatures, and even a fifth state called fermionic condensate. Who knows what else we'll discover? If you liked this video, please give it a thumbs up and share it with your friends so they can become scientists just like you.